Okay, I'm gonna go in reverse today. Today is kind of a review because we'll have a quiz Monday. So I'm gonna hand out this review stuff, and I think I have come up with a better way to present how to find the equation when looking at the graph. I think I have.
345. Do you have your stuff? Yeah. 345 at the first, and also they're giving us 3/4, or yeah, like 3/4 of the field. And varsity is only taking like a couple.
That's lit.
Varsity is basically set.
Varsity sucks.
Varsity's
So how's the day
yeah,
going?
really good.
Hey.
Whoa, Mr. Strip.
Yeah, varsity sucks.
Hey,
Okay, why does
class
varsity
still
suck?
going on? Tell me why you guys
Varsity's
don't
like
stop.
9/10
Yeah,
freshman.
Yeah, that's because Schneider can't make his own decisions.
Haley Hodstead,
All he does
Laura
is be like,
Sanchez,
oh, you're on EC now? Oh,
Riley.
you must be good.
And I
So
think they're on
like
video.
varsity level. They're gonna get
Margie doesn't want to make varsity though. Margie
If
said
they
that she
think
would
that
turn
they
it
can
down.
take all the freshmen from EC now and put them in play varsity.
Yeah, wait,
They
what?
will not be able to do
What
it.
about you? Wait, is Hannah?
I'm just not JV.
But is
Hannah
it
Blonde,
like-
Hannah?
I don't really care.
She's
Yeah.
no
Because
senior.
JV is like
Oh,
a fun,
senior
it's not
Hannah?
as intense as
I know.
varsity.
Hey, everyone got everyone have a copy of the notes?
In college.
What about
I don't play
Ellie
soccer
Gill?
in college.
She's
Like,
always
I just
been
here
on
to have fun.
Okay, ready,
Ellie
set,
Gill is
Going.
freaking
Dude,
insane.
she's so annoying.
Is she?
Like, she's so
I love Ellie Gill.
all right. First thing I'm gonna do, let's see, I'm gonna add a few of these.
I love her.
Like, she's being dead.
Oh, I know she is. Of course she is.
This is an 80 conversation. She's
Wrong with that. Don't deny it's not. Hey,
What's up?
I'm going in reverse today, so we're gonna start with
Why are you
notes.
always late? Shut up, Cooper.
Shut up, Cooper.
Walk
You have no right. You're playing Fortnite, bro.
Walk your
Cupcakes, man.
Yeah. Pookie.
What'd you say?
I said
Forgot about
Pookie.
that.
You heard
He
me.
said Bookie,
What'd
that's
you
what he
say?
said.
You heard me the
You're a
first
bookie?
2 times. I'm not trying to say it 3
I'm gonna
times.
lay a dime on me.
Pookie.
Bookie.
All right, ready? Sunshine, cupcake, Pookie. Hush.
Your cupcake is soft.
Emma?
Okay,
Your cupcake is soft.
first thing I'm gonna go through is I'm going to define whether it's growth or decay. Is that okay so far?
Pretty sure there's
So what do you think? As it goes to the right, is it going away from the asymptote? Yeah, so growth. Second one, which is the one on the right, I think. Is this grown away from the asymptote as I go right?
Yeah.
So this is also growth. Third one, is it going towards the asymptote or away from it? It's going away or what? To or from the asymptote as we go right.
It's towards.
Okay, so that's decay. And then the last one, is it going towards the asymptote or going away from it? Towards. So decay. So we have 2 growth, 2 decay, right? And that's important that we understand which one is growth, what is growth, and what is decay, because our base that's under the exponent, that number that has the exponent that's raised to it, if it's growth, that has to be a value larger than 1. Okay? If it's decay, it has to be a value between 0 and 1. Is that all right so far? So we're going to kind of think of our equation on this. So we do have this as our equation. So what I would do the very first thing is we know it's growth, so the b value has to be a value that's larger than 1. Everyone okay with that?
Yeah.
So let's define our k value, our asymptote. It looks like in this case, our asymptote is going to be -2 because that's -2. Agree? Does everyone feel comfortable with that?
Yeah.
Okay, so far so good. So we're going to keep that in mind as we progress to the end. Okay, so then we're going to look at the points that they gave us, and we know that this is the point 1, 5. And then this is the point right here that is 0, comma, negative 1. Agree so far?
Yeah, I can agree.
Okay. So all we really have to do is this. When you're looking for a point, you want to make sure your points are 1 away from each other in the x direction. So I go from 0 to 1. So they're 1 away?
Yeah.
Okay, cool. Then what I'm going to do is I'm going to look at this. I'm going to look at the distance from here to the asymptote and distance from here to the asymptote. Well, the distance from here to the asymptote is a 1. And this distance is 5 to here and then 2 more. So this has a distance of 7. Agreed?
Yes.
So as long as they were 1 away from each other, and this was resting on the y-axis, my base is now going to be 7. I'm going to go ahead and ignore the a, and I'm just going to go 7. Does this look like it shifted right or left at all?
Right. Oh,
No.
From here? No. So we're going to call it 7 to the x minus 2. Done.
Does it go down too? Oh yeah.
That's why I have that minus 2. So the first thing is you define whether it's growth or decay. We're not really going to stretch these too much. I mean, they could stretch where we have to focus on the a value, but mathematically, in order to do that, it's a little bit tougher to do at this point, so we're not going to see it. Okay, does everyone feel comfortable with it? This problem's done. Okay, and of course, if it says, hey, what's the domain of this? The domain goes negative to positive infinity, and the range goes from whatever the asymptote is to infinity. Cool? All right, next problem. We also said it was growth, yes? So again, I'm just writing my equation up. Okay, we have growth. What does my asymptote appear to be on this one? 4. Okay, because that's 4. All right, so we have to realize what flips it over the asymptote and still is growth. It means I have to have a negative. I have to have a negative with my base. It doesn't mean that I'm going to square that as being negative. It just means I have a negative in front. So I know I have this negative, so I'm going to kind of ignore the a value for right now. And then the values that we have, I have this point up here. I think I have it labeled as 0, 3. And then another point, maybe right here, we'll go with this point. This point is 1, comma 2. Do that right? 1, comma 2. All right. So this right here is a distance of 1 away from the asymptote. That's what we want. How far is this from the asymptote? Look in the y direction. Goes from 2, I'm going up to 4 is the asymptote, so that's 2. Okay, so remember I had that negative because it flipped over and it's growth. So I'm going to go, and there's my equation. Done. Okay, what's my domain? Negative to positive infinity. And my range is going to be flip-flopped to what we think. It's got to go from negative infinity because it's coming down from up here and it's going up to 4. Done. Cool? Everyone set on that? Okay, so for the growth, I'm not changing anything. I'm looking that my 2 points are 1 away from each other in the x direction, which they are. It goes from 0 and then to 1. So that's a bonus. That's why I didn't use that second point down there. Agreed?
Agreed.
I guess if I use that second point, I'd say that distance is 4. And then how far is the one that's 1 away? Well, that's 2, and then 4 over 2 reduces to 2. But the things that I'm looking for on this, obviously, I want to make sure you have that in place. If you're missing that, then you're missing about a point. Okay, this one's decay. Does everyone understand why it's decay?
Yeah.
As I go to the right, I approach my asymptote. Okay? So if it's decay, that means that my base has to be a fraction. It has to be a fraction or a decimal that is between 0 and 1. So this is a regular decay problem because the regular growth looks like this. So this is the decay. So here's growth, decay. Okay? So I'm going to look at my equation. Y equals a b raised to the x minus h plus k. What does it appear that my asymptote is?
-4.
-4, absolutely, good. Okay, so y equals, I'm not really going to be too concerned about the a value. I think it's 1 right now. So I do have this point right here, which appears to be -1, comma, -2. Agreed? And then I have this point right here, and this point here appears to be 0, -3. So from -1 to 0 is a factor of 1, which is great. So remember, we're looking at how far away from the asymptote we are. How far is this from our asymptote?
2.
It's 2 away. How far is that? That should be 1. Okay. Oh, that should be a -3. Apologize. Okay. So I have this 2 over 1. But because it's decay, this is going to flip over. It's going to become 1/2. And it did not shift right or left at all, so it's done. Make a little bit more sense? Yeah.
Couldn't you just do y equals 2 -x?
2 to the negative? Absolutely.
Because I thought you weren't supposed to have like a
You,
b less than 1.
you could definitely have this.
Okay.
Okay. If it's less than 1, that means it's decay.
Yeah.
And that's the same idea. So both of these are acceptable answers to have. Which one's more correct? I like them both.
Okay.
Okay. I'm not going to dock or add points whether you have one or the other.
Sounds good.
Cool. Last one, decay again. Okay. So I'm going to use my equation. Y equals ab raised to the x minus h plus k. Hey, what would the k value be if this was my asymptote? 0. So you could put plus 0, but you don't have to. But if that happened, all right. And then I have this value here, which appears to be, what's my asymptote on this one? 2. So I get plus 2. So y equals something plus 2. I got this point here, which is 0, comma 1. And then I have this point here, which appears to be -1, -1. Is that okay? So again, we're looking for the distance to the asymptote. So this distance to the asymptote right here is 1. Fantastic. What's this distance here? 3. Good. So remember, I get this 3 over 1 ratio, but we have the decay. So what do I do to this? Huh? 1/3. Or, as Coop pointed out, we could have that as well. Whichever answer you want is, and then the domain, negative to positive infinity. The range on this one is, let's see, comes from negative infinity and goes up to 2. Let's go back to this one. I forgot the domain and range here. Domain on this one, negative to positive infinity. Range, it goes from -4 to infinity. Remember, you go smallest value first. So 4 to infinity. The reason why this one's backwards is because as I go left to right, I come from negative infinity, go up. This one, as I go left to right, I come from -4 and go up. Okay? Good? Does that clear that up a smidge?
Yep.
Cool. So definitely, I'm showing you that because you'll definitely see that type of thing on the quiz Monday. Yeah. I will pick them for you. I will have them on the test. It'll be definitely a dot. So you might have to write it as ordered pairs. But Lee, that's a great question. I will mainly give you something on the y-axis, and I will also give you something on the that's not on the y-axis, but they'll be one apart. So that's the clue, or the key, is you want them to have them be one apart in the x direction. And the ones that, for the quizzes that I saw today, they are indeed one apart. Which this, if you can fathom this, so if you can look over this, make sure you feel good about it, we will, you should do just fine. All right, so let's move on in the notes a smidge. And then I'll go back over the homework. I gave you evens last night, right?
Yeah.
Okay. All right, so let's do this first, then we'll go back over the homework. So we're going to talk about growth and decay and some applications problems. It says a fungus grows continuously. So if it's continuous growth, and I will give you all of the growth equations or decay equations. So because it's continuously, this goes with A equals perp, where remember E is the exponential. Okay? So a fungus grows continuously at a rate of 0.08. So how do I, or 0.8%, which is 0.008 as a true decimal. Agree? Move the decimal twice left. And it grows each hour. So time is in hours on this one, which is fine. If you start with 200 grams of the fungus, what part of this equation is 200?
The P.
The p-value. Okay, so that's my p-value. And then how much will you have after 10 hours? How much will you have after 20 hours? So this one's going to be A equals 200, E rate of 0.008. And we're doing this in hours, so times 10. And then this one after 20 hours, same exact equation. And if you did either one on the calculator, I'll just grab a handheld calculator. Doing it.
Dare you.
You won't know that.
I don't know. Find R.
Just make sure to not look at anything from the side.
The doubles.
Just don't mention that to anyone.
And just stay at least like 15 yards away from that damn ball times.
All right, so this has an answer, the top one after 10 hours of 216.7. How do you have a 0.7 fungi? Well, it's just because it didn't round at that exact value. And then this one is 234.7. Okay, how long will it take the fungus to double in size? So if it's going to double in size, that means I'm changing my A value to 400 equals 200 E to the 0.008. And we're going to call that X, where X is going to represent time. We could have made it a T, I guess. So then divide both sides by 200, so I get 2 is equal to E to the 0.008X. Does anybody know how to solve that? I would, so being I have not taught you about natural log yet, this is how I go about this problem. I'm just going to use Desmos. All right, so I'm going to go, one side's going to be 2, and one side's going to be E to the 0.008X. That's 0.0. What's that? Shift 6 to the caret. 0.008, and we'll make it X. And then what was the other one? 2?
Yeah.
Okay. So, oops, I should say Y equals 2. Oops, Y equals 2. Okay. So can I see the lines intersect on this?
No.
No, you'd have to do the same on your graphing calculator, but what you'd have to do is kind of scroll out. So a lot of you would go just zoom out real quick. What I would do on the graphing calculator, it appears that they do intersect here. So it looks like it'll double at roughly 87 hours. Or it'll double in 87 hours. Cool? Make sense? what would you have to do on your graphing calculator on this? I would change the window in the X direction. So if you use your graphing calculator on it, takes a second for this to load, but we'll get it. You'd think things would be a little quicker, but they're not. I'm sorry. All right, so I get 2 for one of my equations. What was the other one? E to the 0.008 x. Is that right? And if I graph them, so if I was zoomed like this, you're going to see like that. So then what I would do is I'd go on here and say, okay, I'm going to change the window and maybe change this to 100. Okay, graph. Is there an intersection that looks like takes place?
Yeah.
What's the command to find where it intersects?
Second, trace.
So I'm going to find the intersection. Enter, enter, enter. And so 86.64, roughly 87 hours. Or 86.6 hours.
Will we be able to use our calculators?
Yeah, there's a part that you can use graphing calculator, and the other part you can use scientific calculator, so that you can have scientific tangent on it.
That was so nice.
Everyone good with that? Can I move on? All right. A 5-year-old car is now worth $18,500. The average rate of depreciation was 14%. So if it's depreciating at 14%, that means that it's growing at a rate of 0.86, or it's growing in the wrong direction. Okay, so depreciation on the car, how much? So let's go ahead and use this. It doesn't say it's compounding, different thing. So I'm going to go ahead and say that I'm going to use my Perp equation. If it says it's compounding a certain amount of times, you have to use one of the others. And again, those will be located on the quiz itself. Okay, so things I know is I know 18,500 equals my unknown, p raised to the 0.86, and then it's a 5-year-old car. So what's my unknown variable up here? P. So I can do this. So I would use the graphing calculator on this one as well. So 18,500. And then let's see, I have x. Oops. I have x second e to the, what was it? 0.086 times 5. Some of you guys chatting too much. Okay, do you agree with that? See nothing. So let's just see if Zoom Fit works for us.
Oh, what's up, Grant?
Grant's in the house.
You're only 20 minutes late. Wait, 30 minutes actually.
All right. So I see the two, but I can't see where they're intersecting. So at that point, so you do a Zoom Fit, and then maybe you do a Zoom Out. Does it look like I can see the intersection? So second, calculate, intersect, enter, enter, enter. So that tells me that my car that's 5 years old, that my 5-year-old car that was 18,500. Oh wait, I goofed up on this. Why did I goof up? I gotta think on this one. What did I screw up on? Oh, I'm not going to do it that way. I'm not going to do it that way. Can I find this value?
No.
Can I find what that is?
Yeah.
Yeah.
Oh, yeah.
So let's do that. I goofed up. I apologize. So I'm just going to get not even graph. So I'm just going to go second e to the 0.86 times 5. So 73.7. So by me finding this, I have 18.5. And then, what did I say it was? 73.7?
3.7.
So if I divide both sides by 73.7, come off. 18.5 divided by 73. Is that what it was? What am I doing wrong? Okay, I'll hold on to this one. Huh? Because it should be increased in value. I gotta hold off on this one. I gotta think on this one. I goofed. I'll come back to it. Come back when my mind's working. So I'm coming back to this one. I goofed.
That means you can't put it on the test.
No, it's going.
Wouldn't you just hold on?
Mathematically, I think everything I did was right. A 5-year-old car. 5-year-old car. The average annual rate of depreciation was 14%.
Would 1850 be?
Because that's what it's now worth.
Oh, yeah.
I don't know why I'm off. I'm off. I'll figure this one out. I'll figure it out. I'll come back to it. All right. You invest $2,400 3 years ago. It's now worth $64.49. If the interest was compounded quarterly, what would the interest rate be on your money? Okay, so this is not going to be the Perp equation because it's compounded quarterly. So this means I'm going to be plugging a 4 in. So I'm going to have P equals 1 plus R over N raised to the NT. All right, so I got to this. I started with this. 1 plus R I don't know. R is my unknown. And this is divided by 4 because it's quarterly. And then 4 times 3 years. So go ahead and run through, start doing the math. So I would say divide both sides by 2,400. So that's going to be 2664. What? 0.49 divided by 2,400. Thank you. So 1.110. So if I divide, I get 1.110 equals this. Okay, now find my rate. What? Right there. Yeah, buddy. All right, I'm going to show you something that, Someone have a graphing calculator out? What is the key that has e to the x on it? ln? Do you agree?
Yeah.
Does everyone see that?
Yes. Sure.
So the ln and the e key are the same thing. So what I'm going to do is I'm going to do a little bit of magic here. And this is a great skill. I'm going to do ln this side, ln this side. So ln is going to modify 1.10. And then what natural log does, it allows you to bring your exponent down front. Is that okay? Okay, now ln is not a variable. Okay, so what I need to do for my next step is I need to divide both sides by 12.
Where is it there?
I'll do that. I'll get a value there. Okay, so
No, that's that one. I swear.
all right. What's the opposite of the ln key? What's the opposite of the ln key? E. So this is going to become an exponent. This is going to become an exponent. When you do this, this is a new operation. That cancels out. So that leaves me on the right side 1 plus r over 4. And on this side I have second e, 0.00869. So this becomes 1.0087. Subtract 1 from that. Multiply both sides by 4. So point. How do I make that a percent?
3.56.
Yep. So my rate is 3.56%. Okay, so the new operations we did with that is we used e and ln. We did ln of both sides here. What ln does is it allows you to bring your exponent down front. And then we went back and then we had to use the exponential to undo it. So that worked out nicely. Okay, we'll work more with that later. All right, finally, graphing these. All right, graph 2 to the x. So I'll do this one blue. So I have an asymptote here. Okay, I graph that first. That's growth because my base is bigger than 1. So if I plug 0 in, I get 2 to the 0. 2 to the 0 is 1. So I get there. If I plug 1 in, 2 to the first is 2. So that's what that one's going to look like. Things that are going to change on this one is this. I have an asymptote at -3. Okay? Things that we know about this. It's the exact same equation, but we have the asymptote at -3, so everything's going to shift down 3. So what I'm going to do is each of these 2 points I know will shift down 3. So 1, 2, 3. And then what's that x minus 2 as an exponent going to do? Shift it right or left?
Right.
Right?
2.
So this point mapped to there. And then this one, same thing. I'm going to go down 3. 1, 2, 3. Shift it right 2. So I get to that. So this point then adjusts to that point right there. Cool? And let's see if I can unmark Grant. Landon show up? Why ain't you working? Goes there. Tardy, yay. Cool. All right, move on. We're gonna graph this parent. We're gonna graph this parent function. So my horizontal asymptote is this. 3 raised to the first. If I plug 0 in, 3 to the 0 is 1. If I plug 1 in, 3 to the first is 3. So this one grows like that. If I do the second one, my asymptote moves up to 2. So everything shifts up 2. And then what does the negative in front of the 3 do? Flips it. Okay? So this is, because of this negative here, it's going to be down this way, like that. So being things are shifting, I'm going to go opposite of this. Then I go opposite. Let's see. So I got an asymptote of 2. So let's just double check. That's a negative right there. I can't see it. If I plug 0 in, I get 3 to the 0. That's 1. Negative 1 plus 2 is? Negative 1 plus 2 is 1. So I still have this value here. It's still consistent. And then if I take 1 and plug it in, I get 3 to the first is 3. The negative out front makes it negative 3. The negative 3 plus 2 is negative 1. Which is about there. This one looks like that. Okay? Cool. Bless you. Moving on. 3 to the x versus 1/3. So we already graphed this one. This one had the asymptote here. So 3 to the 0 is 1. 3 to the first is 3. I have the exact same asymptote. So this is still my asymptote this way. But is it growth or decay? It's decay. So this point's still going to remain the same. If I plug 1 in, let's see. If I plugged 1 in, I would get 1/3, which is, here. And there's your decay. How do we describe the relationships? Reciprocals of each other, I guess. What's that? You good? All right. Graph the function. Highlight the asymptote. State both the domain and range. Okay. Asymptote 0. So y equals 0. There's our asymptote. Let's figure out. So it's a decay model. So if I plug 0 in, 1/5 to the 0 power is 1. 1 times 4. If I plug 1 in, I'm dealing with a fraction, yes? So what should I plug in so I can flip over my fraction?
5.
Negative what? Negative 1. If I make that a negative 1, if I plug negative 1 into that, this gives me y equals 4 to the 5th, or 4 times 5 to the 1st. 5 to the 1st is 5 times, and that was plugging negative 1 in. So negative 120, so it's way up here. That's what that looks like. Good so far?
Yeah.
I plugged the negative 1 in to flip the fraction over that way, but it gave me a large value that was off my graph. But all right, e to the x, and then the other one. Okay, so this has an asymptote still at 0. E to the 0 is 1. E to the first, and this is a value you'll have to know, or if you have a scientific calculator, you can figure it out. If you go e to the first, you wind up with about, e to the first is 2.7 roughly. right? So if I plug 1 in, I get 2.7, which is here. That's the point, 1 comma 2.7.
And then you would move it.
And then this one, what switches? There's 2 switches. What's one of them?
To the
Up
left.
3, left 1.
Up 3.
And it's negative, so.
So that's my asymptote now. And then if I plug 0 in, I get, and it also shifted, which way? Left 1. But that negative out front puts it on the opposite side of the asymptote. So if I plug 0 in, I get 0 plus 1. So I get e to the first. That's 2.7. Negative 2.7 because the negative out front. Negative 2.7 plus 3 is 0.3. Okay. This is
Are we gonna have one like on the
Plug.
test that has like a negative in front of it?
could be. All right. What value can I plug in that would get my e value to be 1? If I plug -1 in, I get e to the 0. E to the 0 is 1. Oh, actually, that point didn't exist, did it? That was, I plug 0 in. Okay. -1. I plug -1 in. E to the 0 is 1. And I'm going to make it a -1 because it's down there. And then I'm going to add 3 to this. You see how I'm kind of tricking it a little bit? So I'm only keeping in the back of my mind what e to the first is. That's 2.7. E to the 0 is 1. And those are some values I'm just trying to make work when I look into this. Okay. Match each expression.
Wait, so was the last one a growth then, but it was a negative growth?
It was growth away from the, negative growth close to the negative. Correct. All right, definition of E. I'd say this is the only one that we could say here. Okay, and I'll give you all of these equations. These equations will be on your test. So let's see, compounded interest continuously. That goes there. Depreciation means I'm subtracting. And that's compounding. And then let's see. So we have that. Let's do this for tomorrow. Make sure we're good for tomorrow. Will you get the odds done on what we did last night? Get the odds done from last night. And then so tomorrow I'm expecting the evens and odds. We'll go over that first. And then other stuff. Look at the review. Look at the review. The review is, what are we on? E?
Yeah.
So look at worksheet E. And see if you come up with any questions on worksheet E. Get out of here, guys, girls. Take care of one another. Have a great day.
Thank you.
Here's D and C.
Perfect.
Thank you.
Awesome. Thanks so much. Yeah, guys.
Whoa.
Yeah, buddy. Awesome. Thanks so much.
Mr. Struggle.
Yeah.